Okay, great. This is a model simulation. The simulation of the tide movement in the estuary in the ocean. And this model simulates the surface water temperature and the currents in the west basin of the Lake Superior. And using this model simulated results of the water flow condition, we can help in solving current environmental issues. That including this arrest of the spread of Eurasian watermeal fragments and the oil spill case in the Straits of Mackinac. So basically what we're showing here is when we use the hydrodynamic model to predict the continuous estimates of the 3D flow condition, and we can release particles here to represent the scenario of the oil spill occurrence. And by looking at the movements of the particles, we can understand or estimate where is the high risk or low risk region if the oil spill occurs. Notice that we use two different colors in this case. If you have the red color, that represents the particles flow with the surface water, which is close to the southeastward. And we have the particle released at the bottom water, which stay here and moving generally into the westward. The hydrodynamics behind this phenomena is that we have a two-layer flow during the summertime in the Strait of Mackinac, meaning the deep water could go one direction while the surface water could go to another direction. And this complexity of the hydrodynamics needs to be resolved by the model to present a realistic flow condition. And further use that information, we could predict to answer this what-if questions, such as what if the oil spill occurred. Of course, this is just a demonstration of how this movement related to the hydrodynamics. In reality, scientists will release much more particles here and repeatedly in different scenarios under different flow conditions to statistically quantify the high-risk region and low-risk region. For example, if you can imagine if you repeatedly release the particles in this region, and in some regions that always be influenced by this particle, then you would identify that as a high-risk region. And in the other region, if you see these particles reach there sometime in some condition, but not in the other condition, that probably has a lower risk.